Okay, got another problem here where I've got two blocks on inclines as shown, connected by the cable as shown, and I want to find the velocity after, let's see here, block B moves up the incline 2 feet, and got a coefficient of kinetic friction I'm looking at. So again, I'm looking for velocity at a specific position. So relating velocity position is generally going to be a kinetic energy problem. Okay, so I'm going to take the total initial kinetic energy, okay, plus all of the work being done between state 1 and state 2 to get my final kinetic energy at state 2. Okay, so when we do this, we take it for the entire system, both A and B. Let's talk a little bit about what um, forces are acting on these. So we'll start with B over here. I've got a tension of T. I've got a weight of 40. I've got what I'll call a normal force at B. And again, I know that B moves up the incline. Okay, so if B is moving up the incline, that means friction is working down the incline, and I'm going to call that 0.1 times NB. That's the friction force. Okay, block A has 2T because of the way the cable is attached there. Okay, it has a weight of 60 pounds. It has a normal force at A that I'll call that. And this one's moving down the incline, right? So my friction force on this one's going to be up that. And that's going to be 0.1 times NA given like that right there. Okay. So I can sum the forces. Okay. And I can learn that NA is 60 times the cosine of 60. Okay, and I can do that by basically, summing in this direction here. That angle right there is going to be 60 degrees, right? So if I sum the forces, right, the friction and the tension are both um, perpendicular to that. So my normal force equals 60 cosine 60. Similarly, for NB, I'm going to get 40 cosine 30 using the same idea there, right? Where I sum my forces in this direction, right? That's going to be 30 degrees, right? So tension and friction are perpendicular, so I just get the 40 cosine 30 equal to NB, okay? Then from that, I can find that FB, just by taking that value times 0.1, becomes 3.464, and FA equals 3, just by taking times the 0.1 normal force. Okay, so that gives you my friction. Again, the normal force is not going to be doing any work because it's perpendicular to the motion of each one of these. So I don't really care about that because, again, I'm going to use work energy, and the normal force is not going to be doing any work. Okay, so now that we know what the frictions are, we start up here. Okay, so my initial kinetic energy is 0. Everything starts from rest. Okay, then I've got all of the work on the entire system going on here that I'm going to worry about. So the first thing I'm going to think about doing is the weights, okay? And this is the work due to gravity. So we'll start with the 40, okay? It's acting straight down. This guy, remember, B is moving up the incline 2 feet, right? So that's 2 sine of 30. And again, I only care about in the direction of the force, right? So yeah, it moves 2 total feet, but vertically in the direction of my weight, okay, that's only going to be 2 sine 30. Now, weight is down, that force is down, motion is up. This is a negative work being done by gravity, okay? Conversely, the gravity on A is going to be positive because it's moving downward. Gravity is downward. This is going to be a positive work, and that's going to be 60 times, now instead of 2 sine 30, A only moves 1 feet because of how the pulley is set up there, right? So if B moves 2, A only moves 1, okay? And again, instead of 30 degrees, it's at 60 degrees, so it's going to be 1 sine 60. And again, that's positive because it's moving down in the direction of gravity, of the gravitational force. Then I've got my frictions. Okay, frictions are always going to be negative because they're opposing the motion. So on block B, I have my friction of 3.64, and that occurs over 2 feet, right? Because it moves 2 feet. Friction and that motion are the opposite directions, but there's no sine or cosine I need to worry about there. Similarly, A is going to be negative. It's going to be 3, but it only moves 1 foot. So the friction done on A is just negative 3 times 1. Okay. Now, the only other force I have here is my tension force. But as you'll see, that tension is internal to the system. So if you think about it, I don't need to actually calculate this tension. Let me show you why. Because whatever the tension is pulling on B, right? So it pulls on B, that tension, that force through a distance 2, right? And that's in the direction, right? T is pulling it up the incline in the motion it's going. A, okay, I have 2T, okay, but that's only over 1 meter. And again, that tension, the 2T, is in the opposite direction of motion. So that becomes negative, right? So 1T is over 2 meters. The other is 2T over 1 meter, okay? And one is positive work, the other is negative work because one is in the same direction, one is in opposite direction. So 2T minus 2T, those go away. So I don't even really need to worry about what those are. Okay. Now the final kinetic energy, I have to include both blocks here. So I have 1/2 60 over 32.2. Again, I'm looking, this would be for block A at this point. Okay, which is that what I'm trying to find? I'm trying to find the velocity of block A. So I'm going to leave that alone, 1/2 VA squared. And then I'm going to have 1/2 times the mass of the other one, which will be 40 divided by 32.2. And instead of the velocity of B, I know that the velocity of B is twice as much as the velocity of A. So if the velocity of A is just 1 meters per second, B is going to move twice that fast, right, at 2. So it'll be 2 VA, and then that whole thing squared like that. Okay, so now plugging into that equation, my initial kinetic energy is 0. Everything starts from rest. I add up all of my work shown in that second part of the equation, which is 2.03. Okay, and then I set that equal to my final kinetic energy, which I can reduce down to 3.42 times the velocity of A squared. From that, I can calculate very quickly that VA is 0.7715, and that is feet per second. So the main thing to take away from this one is that work energy equation is, you only get one equation for the entire system. So you have the sum of all the kinetic energies, sum of all the works on the entire system as you go through, and you just get that single scalar equation where the only thing you worry about is work in the positive or negative, is the force in the same direction as the displacement.